internet connectivity, so we started late. I was probably so it's 9 minutes late, so I'll go over 9 minutes for this live stream as well. So welcome to OneClass. This is Chang, one of your senior tutors. Today we're going to talk about some math problems that ranges from university level to high school to middle school, and we'll start from the hardest problem and go through to the less difficult problems. So let's get started. Cool. Oopsie. So let's look at our first problem. Our first problem is asking us to convert the decimal 0.22222. The dash line on top of the number just means that it goes infinitely. So like it's actually 0.2 is actually 0.22222, and the 2 goes infinitely. And we want to convert this decimal to a fraction by writing it as an infinite series. So looking at this number, we know that is by like the infinite series, we actually write it as a infinite geometric series. So what are geometric series? Geometric series, or like, I guess geometric series, they're just, they're in the form of, or actually let's just directly write the sum of the geometric series. So Sn is referred to the sum of the geometric series, and usually they are just A1, and A1 is the first term of the geometric series, and 1 minus Rn. R is the difference between two consecutive terms, or not the difference, it's the next term in the geometric series divided by the previous term in the geometric series. So it's actually multiplication instead of subtraction. So this is the sum of a geometric series. So in order to find this sum, we need to find the limit. This is just like knowledge about geometric series. So if you haven't heard of geometric series before, this is what you gotta know. And n tends to infinity. N is just like an arbitrary number representing the nth term of the geometric series. So we want to tends to the limit. So like as n tends to infinity, what is the sum of the geometric series? So basically, when the number of terms of a geometric series is infinite, what is the sum of this geometric series? And that would be the limit of n tends to infinity of this expression over here of A1 1 minus Rn over 1 minus R, and we know the we can't really find this difference, but we know that when R, or the difference, is smaller than 1, or is between 1 and 0, or when R is a fraction, we know that R to the power of n, when n tends to infinity, is infinitely small because you're multiplying an infinite number of fractions together, so they're arbitrarily small. So we know this term over here, or let me use another color. So this term over here is arbitrarily small, so it's approximately 0 when n tends to infinity. Approximately 0 when n tends to infinity. So 1 minus approximately 0 number is just 1. So we can simplify this expression to A1 times 1, which is just A1, over 1 minus R, where R is the is the next term in the geometric series divide the previous term in the geometric series. And we know where R is between 0 and 1. So this is kind of an extra piece of knowledge that we need to know about geometric series. Now, let's write 0.2 in the form of a geometric series. How do we do that? We know 0.2 is actually equals to 0.2 plus 0.02 plus 0.002 plus 0. Or I guess I'll just write it like this, and we know like the idea of it. So from here we know that we can write 0.2 or in the form of this, and they are the same. They have the same value. So we know from here, the first term of the geometric series is just 0.2. And we know the difference between the next term of the geometric series and the previous term of the geometric series is 0. Or I guess I should write it in fraction form, is 1/10. So 0.2 times 1/10 is 0.02, and 0.02, or I guess the arrow should go the other way. I'll just write it the arrow in the other direction, so it's not as confusing. Oh, 1/10, and 0.02 multiplied by 1/10 is 0.002. So the difference, or the factor between each of the subsequent term in a geometric series, or in this geometric series, is just 1/10. So we know R is equals to 1/10. And let's just write A1 also in fraction form is equals to 2/10, which is equals to 1/5. Okay, so we know the term A1, is 1/5 in this case, and the term R is equals to 1/10. So the sum of this geometric series, or 0.2, is equals to A1 over 1 minus R, which is also equal to 1/5 over 1 minus 1/10, which is equals to 1/5 over 9/10, which is also equals to 1/5 multiplied by 10/9, which is, you'll simplify it. So the result is 2/9. So in order to write 0.2222 as a fraction using geometric series, this is the process we follow. And we know that 0.2222 has the same value as a fraction 2/9. And let's double check that using a calculator here. Decimals is just a scientific calculator online. I really like it. It's really useful. See? Here we go. We double check our answer, and we know 2/9 is indeed 0.2222. So yeah, this is how we complete this question. And let's look at our sample answer. Yep, they had more explanation of geometric series. I kind of didn't explain geometric series as much, but I explained how to find the sum of the geometric series in more detail. And yep, they did the same thing as us. But they didn't write, they wrote it in the form of geometric series, but they didn't give the fraction. Let me see. Yes, the question asked us to write this decimal in a fraction, but the answer didn't do that. So let's just say needs to write the geometric series into fraction form. Needs to write the generation in a fraction, or needs to convert the geometric series into a fraction. And let's give them a hint. Let's say try to find, or by finding the sum of a geometric series. Okay, and the solution is not actually, or I guess it's correct, but it's not complete, so let's just say it's incorrect. Okay. Oh, what happened? Yeah. Cool, so it's working. Now let's look at our next question, our question number 2. Okay, so the question number 2 tells us that the cube root of 343 is 7, and is asking us how much larger is the cube root of 343.2. And it says that we should estimate this using linear approximation and round answer to 5 decimal places. Okay, so let's do that. So here's our second question. Here's our second question. The information given is that the cube root of 343 is 7, and it's asking us for the cube root of 343.2. So let's do this using approximation. So it's calculus, and we need to find a function. Let's use the function, or I guess we have to use a function, the square root of, or the cube root of x. So yeah, this is our function. And in order to find the linear approximation, we need to use the formula, and the formula of linear approximation is, let's just write in another color, because this is like kind of the knowledge we have, or the preliminary knowledge that we need to know in order to solve this question. So L of x is equals to f of x plus, or I guess we should write it as f of a, because it's linear approximation, where a is just the point that we want to use to approximate, or the y-coordinates of the point that we want to use to give the linear approximation. Okay, so this is our formula. So the first step is to find the first derivative of the function f of x, because we need to use the function f of the derivative of the function right over here. So we know that the function cube root of x can also be written as in this form, and in order to find the derivative, we just minus the power by 1. So 1 over 3 minus 1 is negative 2 over 3, and we pull the power up to the front of the function. So this is how we this is the derivative of f of x. And now we have the derivative of f of x. Let's find the let's find f of a. So the point we want to use to approximate this value is 7. So, or I'm sorry, the point that I want to use to approximate this value, or the point a, is 343. But we know f of a is, or let's just write it down. So a is equals to 343, and f of a, or f of 343, is equals to the cube root of 343, which we already know, given the question, the cube root of 343 is 7. So this would equals to 7. Okay, so we already have the value f of a, and we now need to find the value f prime of a. So f prime of a is equals to 1 over 3, or I guess I should just write a, I should just plug the value of a, because a is 343, written right over here, and we'll just do 1 over 3, x, which is 343, which is a, and to the power of negative 2 over 3. We know, or I guess we need to find this value. Can we just directly find this value? Let me see. So we can also write it in this form. No, we can't directly find this value. It's too hard. Let's just use a calculator then. So we have 343, the power of negative 2 over 3. Okay, so this is our f prime of f prime of a. So now we just use the equation. We have L of x, which is the x we want to approximate. It's 343.2. So let's write it over here. X equals 343.2, and L of 343.2 is equals to f of a, which we already know is 7. Right over here, it's 7. Plus f prime of a, we know is 1 over 3 times 343 to the power of negative 2/3. And that expression is multiplied by x, which is 343.2, minus a, which is 343. So we would find the answer of the linear approximation. We know that it's 1 over 3 times 343 to the power of negative 2/3 times 0.2. And that's our linear approximation. Now let's just try to plug it in the calculator to see what the actual value of that linear approximation is, because the question asks us to round the answer to 5 decimal places. Okay, So let's see. So we want to find 7 plus 1 over 3, or 1 over 3 times 343 to the power of negative 2/3 times 0.2. Oh, whoopsie. And our answer would be 10.26666. Let's just write it down. I can't find, I just dropped my pen. Where did my pen go? Oh shoot. Huh, that's odd. I can't find my pen anymore. Oh well, but I can type the answer. Okay, so the answer is, or my pen is here. So the answer is just 10, and we want to round it to 5 decimal places, which is an odd request in my opinion. So the answer would just be 10.2666, 1, 2, 3, 4, and 5, because 6 is larger than 5, so we round it up. So yeah, this is our answer of the linear approximation. And then it also, but it doesn't ask us the value of the linear approximation. It asks us how much larger is the cube root of 343.2. So we need to find the cube root of 343. So we need to find the difference minus the cube root of 343.2, which is, or I guess need to go the other way around, because the cube root of 343.2 would be larger than the cube root of 343, because 343.2 is larger than 343. So yeah, that will be our value here. 10.26667 minus 7, which would just be 3.26667. Whew, that was a long question, but that would be our answer of the difference between the cube root of 343 and 343.2 using linear approximation. So this is our result. All right, let's look at our sample solution here. So they also use a function f of x equals to cube root of x. I mean, you have to use that function. And then they find the derivative of 343, or they find the value of f of a first, and they found the derivative of 343, or the derivative of f of x, and they try to find the derivative, or f prime of x of a, which is probably correct. I'm not 100% sure, and then they use linear approximation. But right over here, they said that the value of f prime of a is 1 over 143 over here, but then they change it to 1 over 147, which is not correct, I don't think. So let's see. So let's see. So let's see over here. 1 over 3 times, or 1 over 3 times, oh shoot, I think our calculation is wrong, because the 3 is supposed to be up on top instead of at the bottom, because it's multiplied. Oopsie. Okay, negative 2 over 3, and let's fix, let's fix our answer first, and then let's fix their answer. Okay, so our value for f of a, the only thing that changed is our value for f of a. Let's do draw, and then let's do a little eraser. So yeah, that kind of tells us the importance of using a calculator. I'm not really good at using calculators, as you could see. Yeah, we actually don't need to change anything except the final result and the result of this expression over here. Okay, because our expression over here is correct. We just did it wrong while we are typing into the calculator. So we know the value of L of 343.2 is actually 7.00136. Well, that makes more sense that they're asking us to give 5 decimal places. So we just swap it over here as well, and we know the difference is actually 0.00136, which makes sense because linear approximation is quite good in this case, and the differences is quite small. Now let's look at their problem. Okay, now our final result is the same, but their problem here doesn't make sense because their values have changed between 1 over 143 to 1 over 147. Okay, so how do we verify that? Let's just use our calculator to verify that, or verify the result. So it's negative 2 over 3, and then they said 1 over 143, or 1 over 143, and 1 over 147. Into over 3. Okay, so the value of our term f prime of a is actually 1 over 147, not 1 over 143. So their fourth line is incorrect, but they made their changes over here, so their final result is correct. Cool. Okay, so their final result is correct, but the fourth line is incorrect. Okay, and we'll just say solution, the final solution is correct, but you need to get the steps right, or else it's kind of confusing and it doesn't quite make sense because you had incorrect steps and then you had the correct solution, which is odd. Okay, let's just say solution is incorrect. And over here, now we're moving on to our third problem. Okay, our third problem is actually an easier one. It's asking us to find the square root of 128. So let's just do that. Our problem number 3 is asking us to find the square root of 128. The square root of 128. So how do we find the square root of 128? We use prime factorization. Prime factorization. What we do is just, what prime factorization is basically we just find the smallest prime factors of this number, and then we just keep going until this expression is comprised of entirely prime factors, or you can't find prime factors of this expression anymore, and then we can find the square root of this expression by inspection. So yeah, upon looking at this, we know that this number, or 128, can be 2 is a factor of 128 because any number that ends with 0, 2, 6, 8 has a factor of 2, or 2 is a factor of any number that ends with 0, 2, 4, 6, 8. Okay, so we know that 128 is 2 times the number, and 2 times what number? We just use 128 divided by 2, which is 64. And we also know that 64 is a prime factor, or 2 is a factor of 64, so 64 divided by 2 is 32. And 32 is also a factor of 32, so we just do 2 times 16, and then we do 2 times 2, or 2 times 2 times 2 times, and we know 16 is like 4 2's multiplied together, so we just do 2 times 2, or 2 times 2 times 2 times 2. It might be easier from here because from here you also know that 8 times 8 is 64, so you might be able to get your answer directly from here. But we'll just do the full step because our audience is like everyone. So yeah, and let's count the number of 2's. We have 1, 2, 3, 4, 5, 6. We have 7 2's. So let's just do 2 times 2 to the power of 6. So that's 7 2's in total. And that would be this, we can just split the terms, and we know from over here that the square root is also the power of 1/2. So we know that these two expressions are equivalent, and we know that 6 times 1/2 is 3, and we know that 2 cubed is 2 times 2 times 2, which is 8. So we have root 2 times 8, or 8 root 2. So the square root of 128 is 8 root 2, because 128 is not a perfect square. Okay, let's look at our sample solution over here. So yes, they're also trying to factor 128. Yes, yeah, they just directly went with 8 times 8 when they have the 64 over here, and their final answer is 8 root 2. That's perfect. So let's just say the solution is correct. Perfect. Solution is correct. Okay, now let's move on to our fourth problem, which is also asking us the square root of, and it's asking us the square root of 169. This is actually a quite straightforward problem because we know 169 is a perfect square. So, and its smallest prime, or I guess its smallest prime factor next to 1 is 13, and 169 is 13 times 13, so we know the square root of 169 is just 13, and we want to do positive or negative 13, because negative 13 times negative 13 is 169, and 13 times 13 is also 169. Cool. So the square root of 169 is just positive or negative 13. Let's look at their simple solution here. Yeah, they just said 13, but that's fine because it kind of depends. If you're like in middle school or like middle high school, the teacher is probably just going to be like, yeah, the square root of something is like just 13. But when we get to higher level math, they're going to say it's both positive 13 or negative 13. I'll just like say correct over here and probably say negative 13 is also a solution. It's also a solution, but I guess it depends on who you ask or like which level of schooling you're asking. So like I'll just say the solution is correct, although they didn't mention negative 13. Okay. Now let's move on to our fifth problem over there. So our fifth problem is asking us for the prime factorization of 18. So it's really similar to what we did before, but it's probably shorter because 18 is a smaller number. So the prime factorization of 18. So we know any number ends with 2, 2, 4, 6, 8, or 0 has 2 as their factor. So we know 18 is 2 times a number, and we know 18 over 2 is 9, so 18 is 2 times 9. And we also know 9 is 3 times 3, so we have 2 times 3 times 3, and this is the prime factorization of 18. So 18 is 2 times 3 times 3, and that's the prime factorization of 18. So yeah, let's look at their steps. It's correct. Okay, let's just say the solution is correct. Excellent. Excellent. Okay, and the next question is asking us what is the value of the square root of negative 25. So, whoopsie. So we know, let's take the negative 1 out. And so we know negative 25 is negative 1 times 25. Again, we can split the terms. So we can split the term into negative 1 and the square root of 25. The square root of 25 is really straightforward. It's just 5. So we know this is 5 root negative 1. Now, I'm not sure if you've come across this before, but the square root of negative 1 has a special symbolic or special meaning in math. or not a special meaning, but it has a special name in math. We usually in math we use, or in physics, we use I to represent the square root of -1. I is called the imaginary number. Imaginary number, and its value is the square root of -1. So when you get to learning about complex numbers, you're going to see a lot of i's. So yeah, but for now, we're just going to leave it like that because you can talk so much about them. They're used in a lot of places, in math and physics and engineering. Okay, so we know that the square root of -1 is I, so 5 root -1 is just 5i. I guess you can leave it at 5 root -1 over there, but you don't usually do that, or you never really does that, because we use I to represent the square root of -1 in math. Okay, so this is our answer over here. Let's check the sample solution. The sample solution here, yep, they did the same thing as us, and the solution is 5i. Let's just say the solution is right. Good job. Perfect. Okay, so we're at our half an hour mark, and that's the end of our live stream today. Cool, perfect. So that's all we're going to cover for today. Thank you for watching. Again, I'm kind of sorry that I was late. That's because I had some internet problems. But yeah, thanks for coming, and I hope to see you again.